Good. Okay, so we're starting something new today. We're still in factoring. And this is actually another factoring technique. It's called factor by grouping. This is really what you want to use when you have a polynomial that has 4 terms in it. Factor by grouping, okay? I mean, it is a little involved. It's not really terrible, but it's kind of long. I wrote out the steps here. This came up in the other class. The first step is really, I hate to say optional, but I guess in a sense it is. I mean, if you skip it, then it's not terrible. I always like to factor out the GCF from the whole polynomial first. That's really what step 1 is. Now, for the second step, what's going to basically happen is with the 4 terms, you're going to make 2 groups of 2, and you're going to use parentheses to indicate what those groups are. And basically, the rest of the process is you're going to factor each of those 2 groups individually. That's really what's going to happen. Let me just see something. Okay, I thought my microphone was off. If you can't hear me, you can't see the notes, please say something. Okay. So again, you would factor out each of those groups individually and hope that whatever's in parentheses is the same thing, and then you factor that. I know that probably sounds very confusing. I understand. That's why what we're going to do now are some examples. But this is the process. I thought it'd be good to write out. Okay. So these are some examples we're actually going to accomplish. Now, in the steps also, I said to check if the second and fourth term have opposite signs, because if they do have opposite signs, then from the second group, you have to factor out something negative. You'll see some examples today as to why you do that, and also why it's good to have addition between the second and third term. I mean, we have that here already, but again, we'll see some examples today where we change subtraction here to addition. Let's do this one. Now, notice that here, let's get the GCF from the whole polynomial first. We're going to take that out. Okay. Now, looking at this, we can see that there's a non-zero constant term. That's why M here in the GCF, remember the GCF has to look like this. And that's why the M here has to be 0. That's why the M here has to be 0. Okay? Because again, there's a non-zero constant term. In other words, you can't factor out x at all from the whole polynomial because there's a non-zero constant term. Also, we have a coefficient of 1. We have seen this before. If you have a coefficient or a constant term equal to 1, then the greatest common factor among all the coefficients and the constant term is 1. So basically, we get the GCF is 1 times x to the 0, which is 1. Okay. I mean, x to the 0, again, is not really defined, but for now, it's okay. So here, what we're going to do now then is we're going to form 2 groups of 2, like so. So we use parentheses. The first 2 terms go in one group. The second 2 terms go in the next group, like so, as you can see. Okay. Now, each of these groups we're going to factor individually just by getting GCFs. So from the first group here, notice that the smallest exponent of x is 2. the smallest exponent of x is 2. So in the GCF, our m will be 2. We have a coefficient of 1. So just like up here, the b is 1, the greatest common factor among the coefficients is 1. So b is 1. The GCF then is 1 times x squared, which is x squared. 1 times x squared, which is x squared. We factored that out of the first group. Again, each group here, we're going to find the GCF and factor it out. Here we got x squared. We're factoring that out, as you can see. So we have x squared in front. We divide to see what's left over. We have x squared times x cubed over x squared, right? When you divide into each term. Into each term. From the first quotient, we just get x. From the second one, we get 5x squared over x squared, which is 5. Right? From here, again, we subtract exponents. From here, the x squares cancel, and we're left with this. So again, we started out with the polynomial with 4 terms. We found its GCF to be 1. We formed 2 groups of 2. From the first group, we find its GCF and we factor it out like we're doing. That's good. Now for the second group, we do the same thing. So all I did here, let me just say, also, all I did here was from the first group, right? Okay? What I did was I substituted this here in for the first group, right? The first group we factored, we found its GCF and we factored it out. I just substituted in for the first group. That's all I did. Now, let's handle the second group. Okay, so we have 3x minus 15. Let's find the GCF. I mean, I wrote it down here, but there's a non-zero constant term. Excuse me, so m has to be 0, right? The smallest exponent of x. The factors of 3, 1 and 3. Factors of 15, 1, 3, 5 and 15. 1, 3, 5 and 15. Okay. 3 then, let me see if I can mark it up. 3 then, as you can see, is the greatest common factor among the coefficients and the constant term. I mean, we actually could have gotten that without listing the factors, mostly because 3 is a factor of 15. So that would force 3 to be the greatest common factor among the coefficients and the constant term. So b is 3, we have m is 0, right? There's a non-zero constant term, so m has to be 0. The GCF then must be 3. 3 times x to the 0, which is 3. So we factor that out from the second group. That's what I'm doing. Like so, right? We put it in front, we divide. When we divide, right, we divide into each term, as you can see. So we have 3x over 3, that's x. 15 over 3 is 5. Now notice from the two groups, what's in parentheses is the same thing. That's what we want. That's good. That's what we want because we're going to factor it out. Right? So again, here from parentheses, right? we end up with the same thing in both parentheses. That's good because we want to factor that out. That's how we know we made the right choice with the grouping. And so we factor it out. So we factor out x minus 5 to get what's left over, right? We have to divide. And so, of course, we divide into each term in the sum, as you can see, right? And then, there's cancellation, and we get this. So this is what we end up with. So this has been factored to give us this. I mean, you could always check it if you want by multiplying, but we don't have to. I mean, we could do that. Now, it's always good to factor each of these further if you can. Again, if I go too fast, don't be afraid to say something.
Is this just another way of doing the GCF? We're not learning
Well, the technique that we're using is factor by grouping. That's
Yeah.
the whole process.
Okay, so it's nothing since last week. We're still doing a GCF. It's just a different way, right?
Well, we're using the GCF, but it's more than just factoring out the GCF. We factored the entire polynomial here with 4 terms.
Okay, is there a different way you could do 4 terms? Or is it?
Not really off the top of my head, to be honest.
Okay, all right.
Okay. So, good question, though. But again, we have finally factored. So we did use the GCF a few different times. And finally, when the dust settles, we get this product. Again, this is a technique for factoring out a polynomial with 4 terms. I know this is, I understand this is intimidating, but it is important to learn. We'll do more examples. So we get this product. And again, it's really good to keep going, factoring each of these little groups, so to say, these binomials, if you can. I mean, it turns out you can't. X minus 5, that's something you cannot factor any further. X squared plus a positive number, you can't factor that further. So basically we're done. Normally, again, you would keep going further with these. But what I'm trying to tell you here is that you can't.